Welcome to K.S.Rangasamy College of Technology YouTube channel. Myself, Dr. A. Ramesh Kumar, Professor in the Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tiruchendur. Today, the topic we are going to see is Introduction to Simple Mechanism from the Theory of Machines subject. Theory of machines may be defined as that branch of engineering science which deals with the study of relative motion between the various parts of a machine and forces which act on them. The knowledge of this subject is very essential for an engineer in designing the various parts of a machine. The subdivisions of theory of machines: kinematics, dynamics, kinetics, statics. Kinematics, which deals with the relative motion between the various parts of a machine. Dynamics, which deals with the forces and their effects while acting upon the machine parts in motion. Kinetics, it is that branch of theory of motion which deals with the inertia forces which arise from the combined effect of the mass and motion of the machine parts. Statics, which deals with the forces and their effects while the machine parts are at rest. The mass of the part is assumed to be negligible. Kinematic link, each part of a machine which moves relative to some other part is known as kinematic link, or simply we can call it as link or an element. A link should have the following two characteristics. It should have relative motion and it must be a resistant body. The types of links are rigid link, flexible link, fluid link. A rigid link is one which does not undergo any deformation while transmitting motion. Strictly speaking, rigid links do not exist. However, as the deformation of a connecting rod, crank, etc. of a reciprocating steam engine is not noticeable, they can be considered as a rigid links. Flexible link. A flexible link is one which is partly deformed in a manner not to affect the transmission of motion. For example, belts, ropes, chains, and wires are flexible links and transmit tensile forces only. Fluid link. A fluid link is one which is formed by having a fluid in a container and the motion is transmitted through the fluid by pressure or compression only, as in the case of hydraulic presses, jacks, and brakes. The types of rigid links are binary link, ternary link, quaternary link. When there is two nodes, then it is called as binary link. Three nodes are there, then it is called as ternary link. Four nodes are there, then it is called as a quaternary link. Kinematic pair. The two links or elements of a machine when in contact with each other are said to form a pair. If the relative motion between them is completely or successfully constrained, the pair is known as kinematic pair. Types of constrained motions: completely constrained motion, incompletely constrained motion, successfully constrained motion. Completely constrained motion, there is a square shaft in a square hole. So here we will see only the linear movement in the square hole. So a circular shaft in the circular hole, but the shaft is having a collar on both ends. So there is a only rotary motion. Coming to incompletely constrained motion, a shaft in a circular hole. So here when the shaft rotates, the shaft may have a linear movement as well as the rotary movement. To stop this incompletely constrained motion, we are coming for successfully constrained motion by incorporating a third element known as a load. Here, the footstep bearing is a best example for successfully constrained motion. The footstep bearing carries a shaft which rotates inside the footstep bearing. The linear movement is arrested by the load. So there is only rotary motion. There is no linear motion for this mechanism. Next, coming to classification of kinematic pairs. According to the type of relative motion between the elements, it is classified as sliding pair when the two elements of a pair are connected in such a way that one can only slide relative to other. The pair is known as sliding pair. The piston and cylinder, crosshead and guides of a reciprocating steam engine ram and its guide in shaping tailstock on the lathe bed are some of the examples for sliding pair. Turning pair, when the two elements of a pair are connected in such a way that one can only turn or revolve about a fixed axis of another link, the pair is known as turning pair. For an example, a shaft with the collar at both ends fitted into a circular hole, the crankshaft in a journal bearing in an engine, lathe spindle supported in headstock, cycle wheels turning over their axis are examples for turning pair. Rolling pair, when the two elements of a pair are connected in such a way that one rolls over another fixed link, the pair is known as rolling pair. The better example is ball and roller bearing. Screw pair, when the two elements of a pair are connected in such a way that one element can turn about the other by screw threads, the pair is known as screw pair. The lead screw of a lathe with nut and bolt with a nut. Spherical pair, when the two elements of a pair are connected in such a way that one element with the spherical shape turns or swivels about the other fixed element, the pair formed is called a spherical pair. For an example, the ball and socket joint, attachment of a car mirror, pen stand are some of the examples for spherical pair. So the second category is according to the type of contact between the elements. Lower pair and higher pair. If there is a surface contact between two elements or two links with relative motion, then it is called as lower pair. Sliding pairs, turning pairs, screw pairs form the lower pairs because they are having surface contact. Coming to higher pair, when the two elements of a pair have a line or point contact, when relative motion takes place and the motion between the two elements is partly turning and partly sliding, then the pair is known as higher pair. Example is a pair of friction discs, toothed gearing, belt and rope drives, ball and roller bearings, and cam and a follower. These are some of the examples for higher pair. So the third category is according to the type of closure, self-closed pair. Next one is forced closed pair. When the two elements of a pair are connected together mechanically in such a way that only required kind of relative motion occurs, it is then known as self-closed pair. Example, all the lower pairs are self-closed pairs. Forced closed pair, when the two elements of a pair are not connected mechanically but are kept in contact by the action of external forces, the pair is said to be a forced closed pair. The cam and follower is an example of forced closed pair as it is kept in contact by the forces exerted by spring and gravity. Kinematic chain, when the kinematic pairs are coupled in such a way that the last link is joined to the first link to transmit definite motion, that is completely or successfully constrained motion, it is called kinematic chain. Example, the crankshaft of an engine forms a kinematic pair with the bearings which are fixed in a pair. The connecting rod with the crank forms the second kinematic pair. The piston with the connecting rod forms the third kinematic pair, and the piston with the cylinder forms the fourth kinematic pair. The total combination of these links is a kinematic chain. The kinematic chain is also two types. One is constrained kinematic chain and another one is unconstrained kinematic chain. In constrained kinematic chain, the link number 2 rotates. What will happen? The link number 3 will oscillate. So it will make the link number 4 to reciprocate linearly. But in the unconstrained kinematic chain, when the link 2, that is crank, rotates, the link 3 and 4 are not having a successfully constrained motion, so the link 5 may move forward or backward. So it is unconstrained kinematic chain. Coming to mechanism, when one of the links of a kinematic chain is fixed, the chain is known as mechanism. It may be used for transmitting or transforming motion. A mechanism with 4 links is known as simple mechanism. A mechanism with more than 4 links is known as compound mechanism. So within this, the introduction about simple mechanism is got over. Thanks for watching. Keep learning and growing with K.S. Rangasamy College of Technology. Welcome. Thank you.